Good morning children. Today we are going to discuss some in-text questions and answers from page 81 and 85 from the chapter The Periodic Table. So let's move into the questions. Page 81, question number 1 is, did Dobereiner's triads also exist in the columns of Newlands Octaves? Compare and find out. So for comparison, two tables are given here. One is Dobereiner's triads and the second one is Newlands Octaves. So we know that in Dobereiner's triads, three elements are grouped together and they are called as triads. Okay, such three triads are there in Dobereiner's triads. Alright, so if you check the triads, you can see that lithium, sodium, potassium also coming in the same way in which they appear in Dobereiner's triads. So here the answer is lithium, potassium and sodium constitute a Dobereiner's triad but are also found in Newlands Octaves. Question number 2. What were the limitations of Dobereiner's classification? So there was only one limitation for Dobereiner's triad, which was all the elements could not fit into Dobereiner's triads. We know that more than 9 elements were known at that time, but Dobereiner couldn't make any other elements grouped together as triads. He could found only 3 groups of elements in which he called each group as a triad. Question number 3. What were the limitations of Newland's law of octaves? There are some limitations for Newland's law of octaves. First one was law of octaves was applicable only up to calcium. After calcium, every 8th element did not possess any properties to that of the first element. And second limitation was Newland assumed that only 56 elements existed in nature and no more elements would be discovered in future. But later on, when new elements were discovered, law of octaves was not matching with their properties, or law of octaves failed to explain the properties of such elements. The third limitation is, in order to fit elements into his table, Newland adjusted 2 elements in the same slot, cobalt and nickel. For example, cobalt and nickel are placed along with fluorine, chlorine, bromine, etc., which have entirely different properties. And the element which shows very similar properties with cobalt and nickel is iron. But the place of iron is far away from cobalt and nickel. That was a limitation of Newland's law of octaves. And now the question is from page 85. The question is, use Mendeleev's periodic table to predict the formula for the oxides of the following elements: potassium, carbon, aluminum, silicon and barium. The oxides and the hydrides of various elements are given in the table. The general formula is given. So you can refer the general formula and find out the oxides of these elements. For example, let's check potassium. Okay, potassium belongs to the first group. Okay, the general formula is R2O, therefore it is K2O. Carbon belongs to fourth group in the periodic table. So, and the general formula given is RO2, therefore CO2. Aluminium, you can see aluminium in the third group and the general formula is R2O3, therefore it is Al2O3. Silicon belongs to fourth group, therefore SiO2. Barium belongs to second group, you can see barium here, therefore BaO. Question number 2 is, besides gallium, which other elements have since been discovered that were left by Mendeleev in his periodic table? So the question is, what were the elements other than gallium was predicted by Mendeleev and discovered later on? That was a question. We know that scandium, germanium and gallium was the 3 elements which discovered later, but properties of these elements were predicted long before by Mendeleev. So he called scandium as Eka boron, gallium as Eka aluminium and germanium as Eka silicon. So the other 2 elements other than gallium is germanium and scandium. Hope it is clear. We'll move to the third question. What were the criteria used by Mendeleev in creating his periodic table. So we know that among physical properties, Mendeleev observed the relationship between the atomic masses of various elements. And among chemical properties, he observed that how various elements are making oxides and hydrides by combining with hydrogen and oxygen. So these were the two criteria used by Mendeleev in creating his periodic table. While moving to the next question, the fourth question is, why do you think the noble gases are placed in a separate group? We know that noble gases are very inert in nature and their concentration is very low in the atmosphere. They are inert in nature because they have completely filled outermost shells. Due to these reasons, they are kept in a separate group called zero group so that they don't disturb the existing order of the periodic table. Hope it is clear to you. So we will discuss more questions in the coming class. Have a nice day and thank you for watching.